Hello YouTube, this is Mr. Bakari, and today we are going to verify trig identities. Now this is a follow-up video. I've made a previous video on verifying trig IDs. This is just more examples so we can see some different strategies. So I'm going to work through 4 examples here and let's get started. So first thing is in the top right hand corner, I have provided the Pythagorean IDs just to make sure you are aware of them as I talk about them. I just want to make sure that everybody can see them as I manipulate these equations with them and utilize them. You will also need to be aware of the reciprocal identities and the quotient IDs as well. All right. So the first thing you want to do is you want to differentiate the left and the right hand side. Usually draw a vertical line because when you verify IDs, you only want to work with one side of the equation. Okay. Typically, I will work with the more expanded side because it's easier to condense an expression than it is to expand. But sometimes that's not the case. It depends. You just look, you observe, and if you see something, then you kind of just go with it. So you make that choice as to which side you want to work with. Here, I'm going to work with the left side because right away I can see that I'm trying to simplify this to 1, and 1 plus tan squared x, I can use this Pythagorean identity right here, and I simply can replace that with secant squared x. So now I have secant squared x times cosine squared x. All right. Now I've got to prove that this is equal to 1. I'm going to use the reciprocal of secant squared x, which is 1 over cosine squared x. Okay. And what that does is it allows me to cancel out cosine squared, and all I'm left with is 1, and now I've proven the left equals the right. And I'm done. Okay? So there's an easy one to get started with here. Let's look at the second one. So this one, I'm going to work on the left side of the equation. And the first thing I'm going to do is I'm going to rewrite tangent in terms of sine and cosine. So using a quotient ID, tangent theta is simply sine theta over cosine theta. And I've got that plus cosine theta over 1 plus sine theta. Now looking at the right, I know that I have to combine these. So I've got to get a common denominator here. So I'm going to multiply the right side by cosine theta. And I'm going to multiply the left side by 1 plus sine theta. Okay. So now I'm going to multiply this out. So I've got sine times 1, which is sine theta. And then sine times sine, which is plus sine squared theta, plus cosine times cosine, which is cosine squared theta. And my common denominator when I add these together would be 1 plus sine theta times cosine theta. All right, so I've combined these, and now I need to see if I can simplify here. And right off the bat, on top, sine squared theta plus cosine squared theta using this Pythagorean ID, that all cancels out and gives me 1. So I have sine theta plus 1 over 1 plus sine theta times cosine theta. And as you can see, top to bottom, these cancel out, and I'm left with 1 over cosine theta. Now I'm trying to prove that this is equal to secant theta, and 1 over cosine theta is the reciprocal of secant theta. So now I am done. All right, let's look at another example. Okay, so this one, I see some things here where I'm going to work on the left side. So this is an example of, you might want to work with the right side. I might do the left, vice versa. It doesn't really matter. It's just observe it and see what pops out. Now, what jumps out at me is the fact that first off, I'm going to replace the denominator because I can use a Pythagorean ID up here. Sine squared theta plus cosine squared theta equals 1. And if you manipulate that by moving sine squared over to the right, then you can see that 1 plus sine squared theta equals cosine squared theta. So I'm going to rewrite the numerator here, and I'm going to replace this with cosine squared x. Okay? All right. Now, I do have to expand this, okay, because I've got two terms here. So this is a strategy that you can use, especially when you're expanding an expression, where you kind of break it down into factors. So what I see here is I see sine x over cosine x, okay? And then if I multiply that by 1 over cosine x, I have sine x over cosine squared x. But I also have this minus 1, so I need to subtract 1 over cosine squared x. Okay? So now if we look at this, this is all equivalent to what we have up here. If you multiply this together and then subtract this, we've got a common denominator and we get this expression right here. Now, what this allows me to do is I've got a factor multiplied by a factor minus, so it looks just like this. Sine x over cosine x is simply tan x using the quotient ID. 1 over cosine is secant x using the reciprocal ID, minus 1 over cosine squared x is secant squared x using the reciprocal ID. And now I have proven the left equals the right. Okay? So let's look at one more example. So here we've got this one. And I am going to work with the right. I'm going to, yep. And so that decision is based on this. I'm just kind of thinking out loud here. If I replace cosine squared x with 1 over secant squared x times 2, I know that what I've got to do here is I've got to get secant squared x, perhaps, on the top and the bottom so that I can replace it with 1 plus tan squared x. So that's the game plan. So, and let me multiply these two together. I've got 2 over secant squared x minus 1. Okay, and I've got to combine these. So in order to combine these, I'm going to rewrite 1 as secant squared x, which give me a common denominator. So secant squared x over secant squared x is just simply 1. And now I can subtract, which will give me 2 minus secant squared x over secant squared x. And that's kind of where I was going with this. Now I can replace secant squared x top and bottom using this Pythagorean ID right here. So that's what I'm going to do. I'm going to continue to work over here. I have 2 minus, and I'm going to replace this entire thing with tan squared x plus 1. And on the bottom, I'm going to replace secant squared x with the same. So now I will look over here at what I'm trying to achieve, and I'm going about it, I believe, the right way. I think I'm onto something here. So I'm going to distribute that, which gives me 2 minus tan squared x minus 1 over tan squared x plus 1. And up top, you can see that 2 minus 1 is 1. And on the bottom, we've got tan squared x plus 1, and I believe we are finished. Yep. This equals this. We've proven it, and we are finished. So hopefully that helps you. A few different kinds of strategies on these examples from the previous video. Just continue to practice this. The more you practice this, the easier it becomes. Study your IDs, and I'll see you in the next video.